Good day to you all. Welcome to my channel. Today we are going to be doing mathematics and we are going to be looking at the rules of indices. Okay, so like we all know, there are some certain rules in indices which, before you can be very good in solving initial equations, you must know those rules. So let's dive into the business of today. The first rule on my list here is the rule of multiplication. When you have two initial numbers multiplying each other, you just pick one of the bases. Since the bases here are equal, then you add up the power. That's why I have x raised to the power m multiplying x raised to the power n. It's also the same thing as pick one of the x and then add up n and and m, because of what? The bases are equal, so you pick one of the base and add up the powers. Example that we have here, you have 3 raised to the power 4 multiplying 3 raised to the power 2. Instead of you to come and start doing 3 times 3 times 3 times 3 4 places, then multiply it by 3 times 3 2 places, which is that is what this means. Instead of you doing that long process, you just come and say it's equal to 3. Pick one of the bases since they are equal, then sum up the powers. 4 plus 2, 4 plus 2 gives 6. Okay, so when you type 3 raised to the power 6, whatever it gives you on your calculator, you put it down. So that is that about rule 1. Rule 2, when you have the same terms but now they are separated by what? Division sign. When you have any two initial terms dividing each other, you just pick one of the base of that terms and then subtract the powers. In the case of multiplication, we added the powers, but in the case of division, we have to subtract the powers. So you now have x raised to the power m dividing x raised to the power n is equal to x raised to the power m minus n. Okay, so for example, if you have x raised to the power 3 dividing x raised to the power 5, is also the same thing as pick one of the x since the bases are equal, then subtract the powers. 3 minus 5, you now have 3 minus 5, which will give you what? Automatically x raised to the power minus 2. So that's that about that. So number 4, when you have an initial term in a bracket multiplying raising to another power, okay, you have x raised to the power n, everything in bracket raised to power m. The same thing as pick that x, then raise to the power of the multiplication of those two terms, the one in the bracket and the one outside the bracket, which gives us x raised to the power m times n. Okay, so we now have it this. So example we have here, we have 2 raised to the power 3 all in bracket raised to the power 2x. The same thing as 2 raised to the power 3 times 2x. Okay, so which will automatically give us 3 times 2 6, which will automatically give us 2 raised to the power 6x. Okay, so the fifth rule here, we have anything raised to the power 0 equal to 1. So let's represent the thing as x. Any term in mathematics, let's say is 10, for instance. 10 raised to the power 0 equal to 1. 2 raised to the power 0 equal to 1. 2 raised to the power 3, everything in bracket raised to the power 0 is equal to 1. So anything in math raised to the power 0 is equal to 1. Okay, so the sixth rule here is the fractional index or the inverse index. So if we have a term raised to the power of 1 over anything, is the same thing as the that nth root of x. Okay, here we have n, so the same thing as the nth root of what? Of x. X raised to the power 1 over n is the same thing as the nth root of x. So if it was m here, it's the same thing as the mth root of x. So we have an example here. 27 rather raised to the power 1 over 3 is the same thing as what? The third root of 27. Automatically the third root of 27 give us 3. Okay, so that's that. Then in the case that we have a fraction having numerator and denominator, that is x raised to the power m all over n. X raised to the power m over n is the same thing as the denominator will serve as the root of that x, but the numerator will serve as the power. So you now have it as root x all raised to the power m. For instance, we have 49 raised to the power what? 3 over 2. What you have here is this 2, which is the denominator, means square root. So it now be square root of what? 49. Then the 3, which is the numerator, is now the power. Everything raised to the power 3. And square root of 49 gives 7. So 7 raised to the power 3. And 7 raised to the power 3, when you type it on your calculator, whatever it gives you, you put it down. The next rule on my list here is the equality rule, the ones that you consider to show whether the powers of indices are equal or not. So when you have the basis of initial equations separated by equality sign being equal, then the powers automatically are equal. But in this case, we have x raised to the power m equals to x raised to the power n. That means that m equals to n. Because if we are to put 3 here, 3 raised to the power m equals to 3 raised to the power n. Let's say, for instance, the m here becomes 2. 3 raised to the power 2 equals to 3 raised to the power n. Automatically, we know that 3 raised to the power 2 gives 9. So 3 raised to the power nothing will give 9 except 2 also. That means n equals to m. So let's look at this example. We have 2 raised to the power x equals 2 raised to the power 4. This means that we can write this thing as 2 raised to the power x equals to 2 raised to the power 2, right? So if 2 raised to the power x 2 equals to 4, then 2 raised to the power what will also give us 4 is also 2. This therefore means that x equals to 2. So that's that about that. So let's go to the next rule. The next rule is the inverse rule. When we have a number raised to the power minus 1 or negative of any term, it's same thing as the reciprocal of that number. Okay. So here we have x raised to the power minus 1 is same thing as the reciprocal of that number. That is inverse of the number. So here we have 3 inverse. 3 inverse means what? 1 over 3. So you can be asked what is 1 over 3. 1 over 3 is the same thing as 3 raised to the power minus 1, which is this. So when you type it on your calculator, you have 0.333. And also when you have the fraction as denominator and having numerator and denominator, everything raised to the power minus 1 is the same thing as saying you reciprocate the fraction, bring the denominator to become the numerator and bring the numerator to become the denominator. Then the negative sign will cancel. So and also knowing that anything raised to the power minus 1 is same thing as 1 over that thing. So the whole of this thing in bracket is raised to the power minus 1. Therefore, it's the same thing as 1 over that whole thing. Okay, so you either write it like this or like this, you are correct. So let's take an example. We have 27 over 9 rather. So 27 over 9 is the same thing as what? You reciprocate the fraction, then it will come up with minus 1. So you now have it as 9 over 27, everything is by minus 1. When you type this on your calculator, whatever answer you will get, and you type this also, whatever answer you will get here and here will be the same. So also whatever answer you get here will be the same. Okay, so 1 over all of this, just following this rule. So the 10th rule here is the rule that is filled up with infinity. Anyway, this one is not necessary, but I just have to put it since it is also true, the true statement. So we have it that any term raised to the power of infinity is also what? Is also infinity, except for one, except if x is not equal to 1. Because we know that 1 raised to the power anything is still 1. Okay, so here we have 3 raised to the power infinity is also equal to infinity. 10 raised to the power infinity is also equal to infinity. The same thing applies here. When we have an infinite value of number raised to the power of any number is equal to infinity. Okay, so thank you very much for watching this. Hope you enjoyed this video. Watch out for my next video where we'll be taking complex examples of indices, where we'll be needing to apply the knowledge we just gained from here. So thank you very much for watching.